Welcome to Simultaneous Equations Substitution Method. We're going to have a look at three different ways that we can actually solve simultaneous equations using this method. So for method one, if A is equal to B and A is equal to C, then that means that B must equal to C. And we're going to use this to solve our simultaneous equations. So our first one, if y equals 3x plus 6 and y equals 4x plus 4, how do we solve this? Notice that we have y equals in the first one and y equals in the second one, which allows us to use the rule at the top for method one. So with that in mind, that allows us to have 4x plus 4 equal to 3x plus 6. Moving the x across, so subtracting 3x from both sides, we get x plus 4 equals 6. Subtracting 4 gives us x equals 2. And then we substitute x equals 2 into the first equation, giving us y equals 3 lots of 2 plus 6, so y equals 12. So the solution for this simultaneous equation is x equals 2, y equals 12. For our second method, if one variable is the subject of an equation, so one variable, meaning x or y, subject of an equation means that it's by itself equal to, then we can substitute this variable into the other equation. So here's our second example. Y equals 2x plus 5. Note, the y is the subject of the equation because it's y equals. And our second equation is 2x plus 2y equals 16. So note the red that says y equals 2x plus 5, and we're going to take that y and substitute it in to the second equation where the y is. So the second equation becomes 2x plus 2 lots of what the y equaled to in the first equation, 2x plus 5. Equals 16. Expand your brackets. 2x plus 4x plus 10 equals 16. Collect like terms, and we're going to bring minus the 10 across. So 2x plus 4x is 6x, minus the 10 across, 16 minus 10 is 6. Divide by the 6, so x equals 1. Substitute x equals 1 into the first equation, and we get y equals 2 times 1 plus 5, so y equals 7. So for this simultaneous equation, the solutions are x equals 1 and y equals 7. For our third method, so in this occasion you don't get one variable as the subject of the equation. So you actually have to rearrange one of the equations to make one variable the subject. And then you go and use method 2. So if we're going to solve 2x plus y equals 7 and 3x minus 2y equals 7. Note on the first equation, 2x plus y equals 7, we have y by itself. So I can actually move the 2x across to the other side. And you'll see that by moving the 2x and minusing the 2x from both sides, we get y equals 7 minus 2x. Now using method 2, we now take that y and substitute it into the second equation. So we get 3x minus 2 times what y was in the first equation. So 7 minus 2x equals to 7. Expand your brackets. 3x minus 2 times 7 is minus 14. Minus 2 times minus 2x becomes plus 4x equals to 7. Collect like terms, and we'll also add the 14 over to the other side. So 3x plus 4x is 7x. 7 plus 14 is 21. Divide by 7, we get x equals 3. Substitute x equals 3 into the first equation. Now I'm using this from the page before. 2 times 3 plus y equals 7. So y equals to 1. So our solution to this simultaneous equation is x equals 3, y equals 1. So as a recap, method 1 If A equals B and A equals C, then B equals C. Method 2, use the subject of the equation to substitute. Method 3, rearrange one equation to make one of the variables the subject, and then use method 2. A shout out to Grace, who all year has added a comment and a smile to her submissions. Thank you.